Welcome to Spring LIB.
Hi everyone, so what we have here today is a particle that has a mass of 0.5 kilograms that's moving along a vertical slot, and that's being pushed upwards by the rotation of an arm. The arm has a constant angular velocity of 2 radians per second, and the distance from the point of rotation for the particle is given by 0.5 divided by cosine theta. And what we're asked to do is, at the instant where theta is 30 degrees, we're asked to solve for the normal force on the particle and the force of the rod on the particle as well. The way we're going to be solving this problem is using our knowledge in normal and tangential and radial motion. And we're going to be using free body diagrams and developing equations of motion to solve for these forces. So what we can do first is we can go ahead and solve for our r dot and r double dot. So we know that r is equal to 0.5 divided by cosine theta, which is just equal to 0.5 secant theta. Therefore, we can say that r dot is equal to 0.5 secant theta times tangent theta times theta dot. And then our r double dot will be equal to 0.5 secant theta tangent theta times theta double dot plus 0.5 secant cubed theta times theta dot squared plus 0.5 secant theta tan squared theta times theta dot squared. So at 30 degrees, which is equal to our theta, we know that theta dot is equal to 2 radians per second, and theta double dot is equal to 0. We know that r is equal to 0.5774 meters, r dot is equal to 0.667 meters per second, and that r double dot is equal to 3.849 meters per second squared. So we can go ahead and solve for accelerations in radial and theta directions. We know that r is equal to r double dot minus r theta dot squared, which is equal to 1.54 meters per second squared. And we know that acceleration in the theta direction is given by r theta double dot plus 2 r dot theta dot, which is equal to 2.667 meters per second squared. Next, what we're going to do is we're going to draw our free body diagram. Here's our particle. Here is our normal force on the particle. Here is the force from the rod. And here is our theta direction. And here is our r direction. So we know that the angle theta is equal to 30 degrees. And that's also the same angle here, which is equal to 30 degrees. Remember that we also have our weight force acting on this particle as well. So resolving our forces in the r direction gives us that np cosine 30 minus mg sine 30 is equal to m times the acceleration in the radial direction. Plugging in for these quantities gives us an np that's equal to 3.72 newtons. Next, doing Newton's second law in the theta direction gives us that F minus NP sine 30 is equal to mg cos 30. Therefore, what we can do is we can solve for F, and we see that F is equal to 7.44 newtons. And that's our final answer, and here's our final answer.